Okay, so a few quick answers to things in the worksheets that I think people in general, I find oftentimes have difficulties with. So just remind you, the impulse equation, these are two new properties, one called the impulse, one called the change in momentum. But what's really important about this equation to understand is that you can actually find one property from the other one. Since impulses cause the change in momentum, and they are equal, I'm saying numerically they're equal, and they have the same units. If you look at the units, and you break these down, and you break these down into fundamental units, you'll see that they are exactly the same. So the way I would think about it is like this. If you buy something, you can pay with pennies, you can pay with cents, or you can pay with dollars. Like if you go to, let's say, to buy a pair of pants. Let's say the pants are $25, and the clerk says that the pants are 2,500 cents. That's technically correct. I mean, it's weird. It doesn't seem appropriate for that situation, but that's technically correct. $25 is 2,500 cents. Or if you, for example, go in and you buy a piece of gum and it costs 5 cents, and the person behind the counter tells you that it's $0.05, that would be weird, but technically correct, right? And this is the same kind of thing. The two properties are equivalent to each other, but they are different approaches to looking at it. One looking at the duration of the force, and the other one looking at how much the momentum is changed by. So what's important to recognize in these is that when you're being asked for the impulse, which is F delta T, that doesn't mean that that's the way you have to solve it. If you have the force and the time, great. Then that's a pretty simple question. You should move on. But if you don't have both of those, then you need to think, well, what other way could I calculate this property? And I could calculate it from the other side. So I can find impulses using the change of momentum. I can find changes in momentum by calculating the impulse. In these problems, where I think you're going to run into a little bit of difficulty is with the direction of things. So for my purposes, just the way that I did this problem, and you could do it in the reverse direction, and the only difference is that your answer would come out to be negative. I chose that the ball was coming in from the right, and I said that that was the negative direction. And then when the baseball player hit the ball, that the ball went back out to the right, and then that would be the positive direction. So therefore, the initial velocity is not 26 meters per second, but it's negative 26 meters per second. And that has an impact in your answer. So if you just take 26 minus 24, that would be if the ball was going at 26 and it slowed down to 24. Okay, that would be an example where that would make sense, where you would just subtract the two numbers. But in this case, the numbers are going to get added together. Now, I could have reversed this and said that this was positive and this was negative, and the only difference is instead of getting positive 50, I would have gotten negative 50. But one thing I wouldn't want you to do is when you go down and you're asked then to make the next step then, because the obvious next step then is once you have the impulse from the change in momentum, then if you were given one of the pieces of information, either one of these, you could solve for the other one. So in this case, I gave you the time over which that force was, that the object experienced that force. And so I end up with the force. And in this case, it's a positive force because it's a positive impulse. In the problem below that one, though, if you run into a mailbox with your car, it's not going to make you speed up. It's going to slow you down. So in the first calculation, where you calculate the change in momentum using the impulse, it doesn't matter to me whether you say the answer is positive or negative, because it's kind of arbitrary at this point. But as soon as you try and take it to the velocity, it really matters that you get the direction correct. So this impulse is a negative impulse. It is not a positive increase in the chain of momentum. It's a negative. It's a decrease in the amount of momentum that this object has. So if you don't put that negative sign in, then what will end up happening is you'll end up getting that it had a faster velocity after the collision than it had before the collision, which doesn't really make any sense, obviously. The object should have slowed down a little bit. So being careful to pay attention to those positive or negative signs is really an important aspect of making sure that you're thinking through the direction, because these properties all have direction. Force and change of velocity have direction, and you really have to think carefully about those.